Today, I want to show analysts how easy it is to enter the world of big data using the SQL skills that you're already having and use in your current roles. Your first question may be, what is big data? I'm going to give you a SIGRA's 3 V's: volume, velocity, and variety. Large amounts of data needs to be analyzed quickly in different types of structured and unstructured data. So if you look at these examples given of YouTube and Facebook, previously we did have websites where people would log into and upload data. But the difference is, if you look at Facebook, 30 billion pieces of content were added just last month for 600 million plus users. We didn't have those things 20 years ago. Same thing with YouTube. More than 2 billion videos were watched on YouTube yesterday. That's an extreme amount of streaming. And if you think about it, YouTube is not even the largest video streaming website on the web now. So big data is, well, big. And there are a lot of tools that you can use in big data. I want to introduce analysts into a few tools they can use to query. So the first part is actually importing your data. We need to get the data imported before we can query the data at all.
How do you get the data? If you're working at a company, somebody probably will supply you a data set that your company generates through interactions with customers or IoT devices or Internet of Things devices. But if you're not working at a company and you'd like to go out and get data sets, there are ample amounts online. If you just go to Google and type in data sets, you're going to find a lot of different results. Kaggle is one of the examples that I'm pulling up now to show you for different data sets like 911 calls or NBA shot logs. Another one is data.gov, and this is the US government having various data sets from different branches of the government that they supply online for people to do research on. Another example is Amazon. Their AWS Cloud has public data sets. One example, the Million Song data set, shows you that the million songs collected has enough information for the size of the data set to be 500 gigabytes. We're not going to download that one. What we will use is the United Kingdom's road safety data. We're going to download a data set and then import that into Hadoop, our big data system. I'll scroll down and click on download the CSV. The CSV contains multiple files, and it represents road safety data from 1979 up until 2015. And I'll just save that to my local computer. After downloading, I'll navigate to my download directory, double-click on the zip file which extracts it, and then navigate into the folder. Notice it's 3 different files. We'll open one in Excel and view the contents of the data. This file was only 9 megabytes, but has 186,210 rows. So imagine if we would have got that 500 gigabyte file. It would have been quite a lot of data, which is not too much data for big data. So now that we have this information, let's enter this into our system. I'm now at the web interface into my Hadoop cluster. Hadoop is open source technology utilized by a lot of companies for their big data and analytics needs. 2 of the leaders in the industry are Hortonworks, who has a Hadoop platform, and Cloudera, who also offers their own Hadoop platform. Both of them offer an interface that you can download and use locally, but the Hadoop interface that I'm using will be stored in Amazon's cloud. I'll log in with my credentials, and then navigate to the file system. The file system is called HDFS, or Hadoop Distributed File System. This is one of the benefits of using Hadoop, is that it has a distributed file system. So rather than having to load up one computer with a lot of disk space, you can now take advantage of the processing power, memory, and disk space across thousands of computers. So let's upload our file. We're going to put it in User, Hive, Warehouse. To upload the file, we click Upload, and then navigate to the directory the file stored in. I click the casualties data, and then click Open. The file is now successfully uploaded. We have now successfully imported the dataset into our big data or Hadoop system. Part 2 is going to be creating a database and tables from the data that we've imported. I'll navigate back to my web browser, and then I click on Metastore Manager. I can see that I have 2 databases. One is default, and one is UK traffic history. In this situation, I'm going to use the existing UK traffic history database, but if I wanted to, I could hit this plus sign here and create a brand new database for my data. In UK traffic history, I already have a table, but I want to create another table. I'll click the icon that indicates create a new table from an existing file. I'll give my table a name. Leave the description blank, and then navigate to the input file. Click Next. If you notice, this is a preview of the CSV file, and we can see that it looks the same as when we opened it in Excel. I'll click Next. This gives me an example of the data types, and then gives you 2 sample rows to make sure that you match up the correct data type with the correct data. Everything looks good, so I hit Create Table. We have now successfully imported our dataset into a table, into the UK traffic history database. Let's go to the next step. Now that we've entered the data into a database, now let's query that data, get the results that we're looking for, and then export that so we can use it for data visualization later. From my web interface, I navigate to Query Editors, and then choose Hive. Hive is a SQL query engine that sits on top of Hadoop, and allows you to make queries across the datasets that are spread across your Hadoop cluster, which could be one node or could be thousands of nodes. So looking at my left-hand side, I can see I'm in the UK traffic history database in the 2 tables. I want to query the casualty data, so I'll write a select statement, limiting my results to the top 10. So right now we're playing the exciting role of an insurance analyst who needs to go through the data and make some decisions. So let's run this query. It looks at pedestrian location and then gives you an average age of a casualty in that area, and then also shows for only males. My results show the average casualty age based off of location. Right now location is represented by numbers, but those numbers coincide with city names. For instance, 0 would represent London, 1 would represent Glastonbury. Let's run the same query but change the sex to the female. You notice now we have different results, and in more obscure locations, there have been no female recorded casualties. Let's return to our original query. We now have the results showing the average age of death by city for males. We want to export this data so we can put it in some type of data visualization tool so we can present this to other people. To export, I navigate to the symbol and click Save the CSV. I go to where the CSV is downloaded and I double click. This opens my CSV in Excel and allows me to manipulate the data like I would any other Excel worksheet. We've now arrived at the last step, which is after we export the data from our big data system, putting it in some data visualization tool where we can show this off to others to where they can easily understand what we're trying to display. There are a lot of data visualization tools, Tableau, Chart.js, and the list really goes on. I think for Analyst, if you're going to work for another company and utilize these tools, Tableau seems like one that is good to invest your time and energy in learning. If you're doing things in your spare time, then there's some other open source tools that may suit you better. For this quick example though, we're going to use a web-based tool. That tool that we're going to use is called Data Wrapper. It's very simple to use and you can make a data visualization chart in under a minute. I'll start by clicking Create Chart. Create Chart brings us to the wizard. First we'll start by uploading data. You can either click here to upload your file, or you can just paste the data in. This data set is simple enough that I just pasted it in rather than uploading a file. But notice also I replaced the numbers with actual city names to make the visualization a little bit cleaner. I take a preview look at the data and everything looks okay, so I hit proceed. It gives you a bunch of different charts. Some charts will make less sense than others. A line chart would make a lot of sense, or a donut chart would make less sense. There's even a map, which would probably make the most sense here. But we need to make sure that we enter the coordinates of the cities in order for the map to populate. For simplicity right now, we'll leave it a bar chart. We also have the ability to refine the graph. So I can change attributes here. And change attributes here. Such things as the title of the graph. We'll hit proceed, and then choose publish. And now we have our completed chart that we can grab information from and embed into our website, or share with friends through social media. So in conclusion, we talked about big data. We got two examples from Facebook and YouTube of the large amounts of data that companies sometimes generate. And then we've looked at some tools and how to do analytics on that large amount of data, namely Hadoop and Hive for querying Hadoop. Hive, along with Spark, Impala, Presto, and other querying tools, allow for analysts to use their existing skills with SQL and bring that to big data without having to learn a brand new language. And the web interfaces are designed to be simple and intuitive, so there's not too much of a learning curve. So hopefully something that you've seen today has sparked your interest, and you can go out and learn more about the technologies that were presented. I really hope that this has been helpful, and thanks for watching.